How are you all? I hope you all are doing well. Myself, Swapnil sir, and we have started lecture series on CSIR NET SET Gate and other competitive exam. So in my today's video, I'm gonna explain to you all one of the question from CSIR NET exam, which is based on supremum and infimum of our sequence of conversions. Okay. So now let's get started our today's example. First of all, I'm going to explain to you all the example and then we'll go for the detailed understanding of solution. We'll see each and every options because question it is from the paper third, that means multiple answer correct question. It is 4.75 marks question. Okay. So question it is quite easy. So we have to check each and every option very carefully. Okay. Now let's get started our today's lecture. Here in our question we have given a and b the sequence of a positive real number. Okay, so a n is given sequence of positive real number. Then we have to find out k, which is equal to limit n tends to infinity, supremum of a modulus of n raised to 1 by n. Okay, k is given this way, and then we have to find out which one of the following option is a true. Okay, so if you observe this k carefully, it seems like it's some standard type of a result. Okay, it's make us remember like a Cauchy-Hadamard formula. Okay, so the Cauchy-Hadamard formula, it says that 1 upon r formula says that when we have 1 upon r, okay, 1 upon r which is equal to limit n tends to infinity, supremum of modulus of n raised to 1 by n. Okay, and limit always exist. Okay, here. Okay, so this is the Cauchy-Hadamard formula is given. Okay, and we have to apply only Cauchy-Hadamard's formula here to figure it out for following options. Okay, we have to figure it out which one of the option is correct, and options are given that if first option, if k which is equal to infinity, then n is equal to 0 to infinity, an r raised to n is a convergent for every r bigger than 0. Okay, this first option. Second option say that if k is equal to infinity, then n is equal to 0 to infinity, an r raised to n is not convergent for any r bigger than 0. If k is equal to 0, then n is equal to 0 to infinity, n r raised to n is a convergent for every r bigger than n. And the fourth option, it says that if k which is equal to 0, then we say that n is equal to 0 to infinity, an r raised to n is not convergent for every r bigger than 0. Okay, now we have to figure it out which one of the option is correct. Okay, and since question it is from the paper third, so maybe there are more than one options are true. Okay, now let us start our today's solution. We'll like go through the detailed understanding of solutions. Our question we have given the value for k. What is the value for k? It is here, which is the limit as n tends to infinity, supremum of modulus of n raised to 1 by n. Okay, and this is exact the Cauchy-Hadamard's formula. Okay, Cauchy-Hadamard formula, it says that 1 upon r limit n tends to infinity, supremum of modulus of n raised to 1 by n. Okay, so this is the Cauchy-Hadamard's formula. Compare this Cauchy-Hadamard formula with the given data. So we write 1 upon r which is equal to k. Okay, the value for k I got it here 1 upon r. Okay, using Cauchy-Hadamard's formula. So first option say that if we take k is infinity, then series n r raised to n is a convergent. Okay, so can we take k is infinity? Okay, so what we write there, 1 upon k which is equal to r. Okay, 1 upon k which is equal to r, and when we take k is infinity, okay, then can we say that series n r raised to n is convergent for every r bigger than 0? Now let us verify. So here we got the value for k. Okay, k is equal to 1 upon r. Okay, or 1 upon r which is equal to k. Okay, so if I choose k which is equal to infinity, okay, so that is 1 upon k which is equal to r. Okay, if I choose k which is equal to infinity, so 1 upon infinity which is equal to r. Okay, and 1 upon infinity which is equal to r means 1 upon infinity is a 0. So we got the r is a 0. Okay, if r is a 0, then we know that if radius of a convergence is a 0, then we say that our power series is not convergent. This is the standard result for Cauchy-Hadamard's formula. Okay, if r is a 0, then series not convergent. Why not convergent? We know that 1 upon r is our given series, and 1 upon 0 if we take it goes to infinity. Okay, then series is not convergent. Okay, so if r is a 0, then series not convergent. So it says that For every r greater than 0, then we will get the series is convergent. So first option is wrong. Second option says that series is not convergent. Yes, exactly true. Series is not convergent over here. Okay, so first option omitted here, discarded first option. Now option number B is correct. Now similarly do it for k is a 0. Okay, option C and D. Okay, so if I take r which is equal to 1 upon k, that means if we take k is a 0 here. Okay, if we take k is a 0, so what we will get? R is equal to 1 upon k and k which is equal to 0. So r which is equal to 1 upon 0. Okay, r is equal to 1 upon 0. This is my r which is equal to infinity. If r we get it infinity, then we say that series which is a convergent. For r which is equal to infinity, series is a convergent. How it is convergent? We know that 1 upon r we define as the Hadamard's formula. So 1 upon infinity which is a 0. Okay, then series is a convergent. Okay, so it is very easier to explain here that we can solve this question just an observation only. So when k is a 0, then we say that series a n r raised to n is a convergent for r greater than 0. So option C is correct. And D given, it is not convergent. So option D, which is wrong. Okay, so D discarded over here. Okay, nothing is difficult, just we have to apply here the Cauchy-Hadamard's formula. Okay, so which is 1 upon r which is equal to limit n tends to infinity supreme of mod L e n raised to 1 by n. Okay, compare this Cauchy-Hadamard's formula with our given k. You will get the 1 upon r which is equal to k, and then apply k times k which is equal to infinity and k is equal to 0. Then you will get the correct option over here. Okay, so I hope you all have understood this solution. Okay, for your better understanding, you may refer my complete solution of this example. So here we can see the solution of by using Cauchy-Hadamard's formula. So I written Cauchy-Hadamard formula over here. So which is having two condition, which is equal to 1 upon r limit n tends to infinity supreme of mod a n raised to 1 by n, and limit always exists for Cauchy-Hadamard's formula. And then we write r is a 0 is a power series not convergent. Okay, r is a 0 is a point where series is divergent, and r is infinity where series is convergent. Okay, so we have to apply this result to our question over here, and then we'll get the required solution. So here in my solution part, for first two option I solved together here, and second, third and fourth option I solved it here together. Okay, so first two option over here, their explanation for first two option, within that first is discarded, second is correct, and third, fourth. Okay, so third and fourth option it is here, within that third is correct and fourth is discarded over here. Okay, so how it is, if k infinity by using first and second option, then 1 upon r goes to infinity, then r goes to 0. If r goes to 0, then we by using Cauchy-Hadamard's formula we say that r is equal to 0, it is the point where series is divergent. Okay, that means series a and r raised to n is not convergent, it is a divergent. So if it is divergent, then surely second option is true here, it says that series not convergent. Okay, and similarly do it for a series third and fourth option. Third and fourth option, it says that if we take k is a 0, then 1 upon r is equal to k, and 1 upon r is equal to 0, then we get the radius of convergence is infinity. And if radius of convergence is infinity, that means 1 upon r is equal to 1 upon infinity is equal to 0. That means series is a convergent everywhere. Okay, so by using option number second, we can say that if radius infinity, then power series convergent everywhere. Okay, so our correct option, which is B and C, and our discarded option A and D. I hope you all have understood my today's example. It is very easy question from real analysis and completely based on Cauchy-Hadamard formula. So even after, if you found anything difficult, let me know in comment section. I will come up with some other videos. So thank you everyone. Thank you for my today's lecture.